Hey, welcome to the Explainer. You ever stop to think about what's really going on inside your calculator or your computer when you type in a math problem? Well, today we're going to pull back the curtain on how they actually do it. And it's probably not what you think.
It all kind of boils down to a simple question like this one. We look at that and our brains just know, okay, do the multiplication first. But how does a simple machine, just a bunch of circuits that only understand on and off, figure that out?
Well, for us humans, it's all about the rules we had to memorize in school, right? PEMDAS. Please excuse my dear Aunt Sally. But for a computer, having to remember a hierarchy like that is actually pretty inefficient. It needs a system that's just straightforward, one that it can process one thing at a time, no questions asked. It needs a much more elegant way. And this is how they do it. On the left, you've got what we're used to seeing. It's called infix notation, where the operators are in between the numbers. But on the right, that's the computer's secret weapon, postfix notation. See how the operators come after the numbers? That simple little change makes all the difference. So this is postfix. You might also hear it called reverse Polish notation, or RPN for short. Now, the real power of doing it this way is its incredible simplicity. By putting the operators after the numbers, a computer can just read the whole thing in one single pass, from left to right. There's no need to look ahead, no need for parentheses, and definitely no need for PEMDAS. It creates this perfectly straight road for the computer to drive down. Okay, so how does a computer follow this roadmap? It uses a beautifully simple tool called a stack. A stack is a type of data structure where you can only add or remove things from the very top. The classic analogy, and it's a good one, is a stack of plates. The last plate you put on the stack is always the first one you take off. Last in, first out. LIFO. And to work with this stack, we only need to know two simple moves. When you add an item to the top, that's called a push. And when you take an item off the top, that's a pop. That's it. Push and pop. And with just these two commands, a computer can solve literally any postfix expression you throw at it. All right, ready to see this thing in action? Let's solve one together. We're going to walk through this expression right here, reading it from left to right, and see what our stack does. First up, we read the number 5. Now, anytime we see a number, the rule is simple. We just push it onto the stack. So, there goes to 5. Our stack now has one item. Easy enough. Next is the 2. Yep, another number. So we push it right on top of the 5. The stack now has a 5 on the bottom and a 2 on top. And here's our first operator, a plus sign. This is where the magic happens. When the computer sees an operator, it pops the last two numbers off the stack. So first it pops the 2, then it pops the 5. It does the math, 5 plus 2, which is 7, and then it pushes the result, that's 7, right back onto the stack. Just like that. 2 numbers went in, 1 came out. Okay, moving on. Next up is 8. That's a number, so we know the drill. We push it onto the stack. The stack now holds a 7 and an 8. Next is 3. You're a pro at this by now. It's a number, so we just push it right on top. Our stack is getting kinda tall. We've got 7, then 8, then 3. Another operator. Subtraction this time. So we do the same dance again. We pop the top two numbers, first the 3, then the 8. Now order is super important here. We calculate 8 minus 3. The result, which is 5, gets pushed back onto the stack. And here we are, the final operator, multiplication. One last time, we pop the 5, then we pop the 7. We compute 7 times 5, and we push the final result, 35, back onto the stack. And now, there's nothing left in the expression to read. And just like that, we're done. The computer's read everything from left to right. Now for the grand finale. We look at our stock, and there's only one number left, 35. That single number sitting there all by itself, that is the answer. That's the result of the entire calculation. No ambiguity, no confusion, just a simple, reliable, step-by-step process that gets it right every single time. You know, this process isn't just some clever little trick. It is a fundamental core topic in computer science. It's the kind of thing you learn in foundational courses like data structures and algorithms. It's really the bedrock of how computers learn to parse information and compute. So why does this matter to you? Well, because this elegant little process is running silently all around us. It's the basis for how programming languages are read by compilers.
It's the logic powering your scientific calculator. It's even how giant database systems understand what you're asking for. Anytime a program needs to make sense of math, this is the system it's using under the hood.
So, next time you use a calculator, you'll know the secret. It's not just some black box getting an answer. It's following this elegant, efficient little dance of pushing and popping. Makes you wonder, doesn't it? What other simple tasks that we do every day are powered by an equally beautiful, hidden process? Something to think about. Thanks for watching.